So Joel contacted Sean and myself, saying that he thinks we live on a heliocentric world and wants to have a respectful conversation about it. And I looked at your Facebook page. It looks like you're a big fan of the James Webb telescope.
Yep.
Okay. I've got a very interesting video coming out on that shortly.
Okay.
And where do you want to start?
Well, I mean, honestly, I got motivated to do this just a spur of the moment. I was seeing, I was watching a little bit of your podcast, and then I was also, I follow both sides a lot. But I also see, of course, the Simon Mantan stuff and Professor Dave stuff. And I hated how they treated you on that freaking video they did 3 months ago, just like making you a laughing stock. I'm like, that's not how to talk about any of this. Like,
because he's not a real professor. If he was a real professor, he'd have respect.
Yeah, that too. But yeah, it's just, I don't know. It's just, even if, like, whether someone's right or wrong, that's not going to ever give you an excuse to, treat them like crap. So I was just
when you don't have any evidence for what you're talking about, the only thing you can do is mock the other side and make funny faces and say, I don't understand when someone's trying to describe to you a perfectly simple concept that blows their argument away.
Nuh-uh.
When I'm making my points and stuff, I might be using some tools that, I understand there's an issue with authority here. That's probably one of the main issues, is an issue of authority, of who we're trusting, the sources that we're trusting. Obviously, you guys don't trust NASA. I don't.
And if they put out something that was real, we might trust them.
Sure. Yeah. So anyway.
Have you seen this James Webb image? I mean, this is...
Yes. Yeah, I've seen that one.
You've seen this one. How about this one? Have you seen this one?
Well, aren't these all just from their basically their log of all their calibration images?
No, I made these on a little app on my phone. It took me 2.5 minutes.
Oh, okay. Well, they would look.
So what I'm saying is my pictures look better than James Webb.
You can still see.
So what do you think that is?
So it's an emission. I think it's an emission nebula. So this region of space that's full of gas. That's.
But let's pretend like the indoctrination camps didn't, and the space magazines didn't teach you all of this information of what these things in the sky are. What if you just walked outside right now with no basic recollective information of what any of these lights are? You it's beautiful, but you're like, I don't know what any of this is. And then you saw this. What would you think it was if you were never told any stories or given any names or any because they've attacked your brain for so long with this stuff, it becomes like it's permanent to you. That's what it is, but that's something someone created. That's something that someone made up and presented it to you, and this is what it's called. And then they go into the real deep CGI images of this shit when they're trying to pretend like they're going to expand it for you, and they're like, that's all composite. But these are hey, I just want to know, like, do you understand what I'm trying to say though? Like,
well, yeah. Right. So you're talking about if I was just out there personally subtracting, whitewashing everything else that that we purport to know about space, what I would think these certain things are. I mean, I'm not sure what I would think. That's why and that's why we've had guys through history probably asking the same thing. That's kind of like how science starts, is like we're asking, what are these things, how is this stuff working? And we've had a long string of people asking these questions. You
see the image I'm showing right now?
Yes.
Is this a NASA image, or is it something that I made while you were talking in the last 2 minutes?
I don't know. I've never.
Okay, good answer. Yeah, but if NASA told you this was the CSMAX Nebula 4205 in the so-and-so region of space, you would believe it.
Well,
you probably would, though. You probably would. Right?
I probably
have to admit that you believe it. Okay,
but
what is the difference between this image and what you just showed me? I think mine's better. I think mine's more believable.
So what your brain's doing to you is saying it's coming up with that word already, the nebula or the this or these space words that we grew up with and other people adults are still about it and showing it and teaching classes about it. We all three of us can create a class and with information. It could be false information, and we could teach our students this for centuries. But the information they're teaching is false. Doesn't matter. You can get an A on your test and feel good about your exam on all this stuff, but it's based off of lies, is what we're saying. So when you actually look up in the sky and see these lights in the sky, that's all we know, Joel. They're lights in the sky. We can't touch them. We can't get there. But you know what? When modern day optics now, the P900, P1000 cameras are zooming in on these, we're not seeing what you see. Apparently we all have different camcorders. Flat earthers have camcorders when we're zooming in with the optics that are able to let you zoom in that far. So if I could zoom in on a hotel 80 miles away and see a window, boom, I'm maxed out zoom. I can't go anymore. I'll go in more. I can't. I'm maxed out. It's a great camera, but only goes that far. And then I do the same thing going up, Joel. Those dots in the sky that you're praising are, probably trillions of light years away. Those dots in the sky would remain dots in the sky as I'm zooming in with the camcorder, man. This Nikon 1000, I zoom in. Those little dots, as I'm zooming on the sky, should remain that size. But they're growing in size, and you can start seeing details on where these things are. Yeah, some of them are out of focus, and some of them are in focus. But it's the point. Use your common sense here. Those little dots in the sky would remain that size as you're zooming. They're so far away, but they're growing in size and clarity as you're looking in. Dude, that's not that far away at all. That would never be able to happen. Whether it's out of focus or not, that can't happen. You just got to use your common sense.
I had access to an observatory all through college, used it, and we're seeing nothing that, when I saw Saturn, I'm like, oh, there's Saturn, right? It's a light. It's not the distances that they're telling us. And I use that, you know what? A lot of times we use the telescope to zoom into the girls' dormitories across campus, okay? And it could only go so far. But then all of a sudden I can see, deep into space, millions and millions of miles. I'm not buying it.
And I'm saying the same thing with the P1000. And that thing's a great piece of technology, and it goes extremely far, and you can see extremely clear, detailed stuff on ground, I'm saying. And of course, we're looking through way more opaque, just funk everywhere in the distance. But the point is that we're looking up with less of that, but I'm just trying to figure out how those dots in the sky are growing in size as we're zooming in. If they're so far away that our own eyes, we're looking at it, that's trillions of miles away. Well, that should remain that way. Or if you're just distorting it and making it bigger, it would just completely blur. I've seen videos of them zooming in on these lights in the sky. They all look different. They all have their own colors, their own little shapes and weird. It looks like something like a frequency vibration with water. And you could reproduce this in your own kitchen. You take a bowl of water or something, glass, something see-through, and turn all the lights off and put a bright LED light underneath. You'll look at your ceiling, you'll see the same thing that we're seeing when we zoom in. This on Dave's screen. You'll see that effect and other effects like these other stars that we've zoomed in on, and you will be able to see the same thing. That's all. That's real science.
Naked eye.
Yeah.
You can see this with your naked eye.
That too. Yeah.
So I'm trying to draw a diagram.
Yeah, but think about what Dave just said. If you look, you can see the naked eye is the upper right thumbnail. You could see that with your naked eye. You zoom in, it gets bigger. You see a little more detail. How can we see these things with our naked eye at the distances they are? I know they sold you on because they're giant things. It's like, no, man. If you actually look up in the sky, most things are the same size, but they're supposed to be trillions of miles farther apart from one another.
And that light is spreading out. Lasers even spread out. Okay, right. So when it spreads out, what is it? Multiplying its brightness. Light doesn't travel for thousands of miles.
So what's happening?
Let alone billions of light years.
So this is what's going on. So let's say we have. It's not going to come up. So, well, there's a couple points there, but I think the biggest thing, since if we want to talk about math, I think it's a good, robust thing that we can all reference. We can all work out for ourselves, which the biggest thing with looking at distant objects is, again, going to be the magnitude of the brightness. Now, when I saw that Needle galaxy, it was super, 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 super faint. So it was about like this, But
they love faint things. When us in the world can go outside and see faint things, NASA, they all love that shit. They love it because they're like, oh, let's enhance it to be this fantasy that you could defend, because you're not going to give it up if you like this type of stuff until you know what it is.
I'm not talking about NASA though. Okay,
I understand. I'm just making a point.
The only time I'm going to reference NASA would be, I was just going to say, the only time I reference something from NASA is NASA's Eyes, which is a software that I think can help explain my perspective on why these things work, specifically orbital mechanics. And I wanted to address the numbers that we're talking about here with orbital speed, rotational velocity, angular velocity, all of this kind of stuff. I think that's where the biggest misunderstanding is, and I understand the misunderstanding. I understand why it sounds counterintuitive when you initially ask the question.
Wait, but back up. Why wouldn't you want to resource NASA? That's the space agency it's like the #1 space agency in the world of heliocentrism. Why would you not want to be like, look what NASA said? Why you don't trust them?
Because I was gonna try to show you guys how it lined up with.
No, but I'm asking you, do you not trust them, or you do trust NASA?
I do
trust them.
But
okay, let's use them then.
Sure, and I was just saying, for the case of the discussion, I'm not going to fully rely on them because I know that they're not a trusted authority by you guys, so you're not going to accept as much.
Joel, let me ask you a question. Joel,
okay.
Let me ask you a question. If I could show you that NASA is faking crap, can we rule them out for anything else that they show you? Can we just wipe out everything? Like, if I can show you them lying,
if I were to
space.
be fully honest, I don't know if I could say that. Just because.
What do you mean? If they're caught in a lie once, if you see with your own eyes that they're lying and they've lied to you, and we can prove that based off of not what we did, what they've done.
That is the magic of engineering. I would wear a mask on my face in a nanosecond, but unfortunately we lost the technology.
It can take days, even weeks, to produce just a single image. The dazzling final results, enough to keep us all dreaming.
The stuff they've actually released and we've caught.
Still gonna believe it.
You're still gonna
believe it? Are you one
that?
of the guys? You believe we went to the moon, right? If one of the astronauts that went to the moon got on a press conference and said out of nowhere, he goes, "We faked it. We never went to the moon. It was filmed in a studio. We did it against our will. Whatever." You'd probably still believe we went to the moon.
I gotta say I'd like to deviate from the moon thing. I think that's a rabbit hole.
Let's soon get out of the sky and get down to the earth with the things that we
I'm waiting to talk about the earth. You guys want to look at pretty lights in the sky.
I just it's a big part of why I have accepted the.
I get it, but pretty lights in the sky, brother, does not prove your lack of curvature. There is none. So
okay, well, with that, let's talk about the speed thing. Okay, okay.
Always remember 666 with NASA. You should always remember that. 66,600.
Okay. Yeah. Well,
not 66.5 or 66.4 or 66.291 or a random speed. 666. Just so you know, because you're Christian. I just wanted to remind you. But go ahead.
Okay. Well, so you guys were asking how. I guess one of the biggest questions. Do you guys agree with the question? How are we spinning at 1,000 miles per hour and not feeling like diddly squat? Is that an agreeable? Fair question that you guys are curious about.
I think I asked that to myself in like maybe 5th grade, but nowadays it makes more sense that it is just not moving. So, yeah.
It's a reasonable question, and I'm curious of your guys' reactions on the answers that could be given through physics, through mathematics. Okay, he's showing okay, I'm kind of glad you're showing the clip.
Yeah, me too.
This is where I'm going to pull the NASA thing in. So we have this Because you're showing that, and that's not what I believe, by the way.
Well, that's what mainstream tells us is happening. You can't pick your battles with the lies, man.
This is what's happening. This is live, or not live footage, but live tracking of what this actually would look like. Okay, so we could go here. Where's Earth?
You're in a video game,
Oh, it's a simulation, but you can...
A video game.
You could line this... I've used this to line up to look at the stars before. So here we have all the satellites and everything. I kind of don't want any of that. Yes, it's a video game, but it's tracking in real time. Okay, so if you were to, for example, look at where the planets are located...
All on a flat plane.
Okay, sure. But over in this direction, we have back here, we got Mars, Uranus, Jupiter, Neptune. And I was just looking at Neptune and Jupiter and Saturn in the same spot in the sky, okay? But this is the speed at which this model purports that we're moving in. Okay, so on this scale of what we're talking about, this is how fast the Earth is rotating, okay? So it's not like that video that you're showing there. I think that did a horrible disservice to anybody who believes the Earth is a globe. This is what it actually would look like.
You're saying this is what it would look like at that scale. But have you ever been on a merry-go-round? A merry-go-round with the horses. Of course you have, right? As a child.
Yes.
Okay? So imagine you're on a merry-go-round that spins around once every 24 hours. You wouldn't even know it's moving, right?
Right.
It would be hard to tell that it's moving. Now let's expand that merry-go-round out to 24 miles in circumference.
Okay.
Well, now you're moving at a mile per hour. Not bad. There's really not much outward force. Now let's span it to 2,400 miles per hour. Now it's going 100 miles per hour. You're on that outside horse.
Yep.
2,400 miles. 2,400 miles. You're going 100 miles an hour in a curved trajectory, okay? You're curving at 100 miles per hour in a big-ass circle. Now expand it to 24,000 miles an hour. You're going faster than the speed of sound in a curved trajectory.
Sure.
And any change in trajectory, you will feel as acceleration.
So imagine two astronauts in space, right? There's nothing else. It's just two astronauts.
Well, you'd have to imagine that. Go ahead.
Okay. All right.
Yeah, you got any footage of that? I'd like to see that.
Okay,
Yeah.
so you have one astronaut. Let's say you're one of the astronauts, and your friend is coming at you, and you pass each other, right? Now you have to ask the question: which one is moving? Okay, which one's? So how would you answer that? I'm curious.
Depends on which green screen guy is operating which camera.
Okay.
Which camera?
No astronaut. Okay, you're just floating in space. How would you answer which one is moving past the other one?
Space doesn't. We don't believe space exists. So you're asking a question about Narnia.
Prove how fast Santa rides his sleigh, bro.
Okay, well, it's a hypothetical. It's a hypothetical to make.
Well, then there's no right answer.
Everything you're talking about is a hypothetical. If that galaxy behind you was X distance away, could we see it? And the answer is no. But somehow you still haven't addressed how we can see Polaris. How can we see Polaris?
The magnitude of brightness. But okay.
But you haven't done the math. The magnitude of brightness is.
Okay.
I mean, can you imagine the sun 64 times brighter than we see it? You can't even imagine it twice the brightness because you've never seen anything that bright. But you're imagining Polaris is 100 quadrillion billion trillion times brighter than the sun in order for us to see it.
Not necessarily. But
not necessarily.
Let's go back to because we need not necessarily because let's go back to let's just stick to the speed question.
Just because.
Right?
They've never proven how far the sun was. They also have changed the distances many times over the years. At some point, it was 1 million miles away, and then it also got up to over 110 million miles away, I believe. And they brought it back to 93. It's like, come on. I mean, first of all, they can't prove how they came up with that, but they keep changing it like it's nothing. That's why he's saying, what if tomorrow they go, hey, by the way, the sun's now 152 million miles away? You're just gonna be like, oh, okay. Well, what do you mean, okay?
That specific issue would be because the Earth isn't in a perfect circular orbit. It's an elliptical orbit, slightly, by a little bit.
I don't understand what you're saying. So you're saying it went from 1 million miles away to 60, I think was the next one, like this, and it was because of something that's happening above us?
I'm not sure that that's necessarily accurate. I mean, I haven't heard the what you're talking about.
Copernicus calculated the sun's distance from Earth to be 3,391,200 miles. The next century, Johannes Kepler decided it was actually 12,376,800 miles away. Isaac Newton once said, "It matters not whether we reckon it 28 or 54 million miles distant, for either would do just as well." How scientific.
Science!
Benjamin Martin calculated between 81 and 82 million miles.
Just 3 bodies, and it goes into absolute insanity chaos mode, and no computer can figure out what it's going to do next. Well, how is it that we have a solar system with 8 or 9 planets, tons of moons, asteroids, comets and stuff that always follow an exact path? How is it possible in this beehive crazy gravitationally run solar system galaxy that we have eclipses in patterns that repeat themselves every 18 years like clockwork?
So
how is that possible?
I guess the one-word answer of that would be mass. So you have to look at
that's a word. That's not an answer. It's a word.
Okay, so the full answer is because, I mean, at least in that simulation you sort of showed, it looks like those are talking about pretty much the same mass of objects. Like those all
No,
three.
it doesn't matter. Big mass, little mass, all the same masses.
Well,
3 bodies together going in orbits, they will go into random chaos mode. And science can't figure it out.
Well, okay, no. Again, like you said, like mass doesn't matter, but that's like the main thing that matters.
No, I'm not saying mass doesn't matter. I'm saying they could all be the same mass. They could all be different masses. 2 of them could be the same. One of them could be slightly different. It doesn't matter. If you have 3 gravitational objects going, this happens. Right?
Okay.
This doesn't look like our solar system.
I understand. I really do. But I'm trying to say that mass is the main determining factor in orbital.
Go ahead. And I'm just saying, look what happened. The whole thing just goes away.
Yeah.
We had planetary alignments this year.
Yes,
like
I saw them. I was out there looking at them.
And so how come they didn't nudge things?
I'm trying to explain. So the more mass there is, that is going to affect. If you have more or less mass, is going to affect how different celestial objects interact with each other. So if
where'd you learn that?
Well, this is math stuff. I mean, I could explain the math.
No, that's what I mean. I mean, how did you learn? I mean, where did you learn this stuff?
Where did you learn? Explain how the 3-body problem is solved in our solar system.
Mass. That's
mass.
It's
a word.
It's the main determining factor of
physics. Physics also.
Yes. Well, it's
math and physics. It's explained. Math and physics. 2 words.
I think we can all agree that math and physics are pretty rigorous process.
I can. Can you tell me the math and physics that show how the 3-body problem resolves itself in our solar system?
Here, I'll show you some example. Oh, it's not going to come
You can't show us anything.
Okay. This is all. Well, this is how we describe curvature of space-time. Okay, so the more mass an object has, you guys have seen the diagrams, the more it warps the space-time around it. Okay, so this is math.
So wait, you're a believer in the bending of space-time and not gravitational. You're a Newtonian, I mean Einsteinian gravitational model, not Newtonian. When did you switch?
Well, first of all, they're not 2 separate things. One sort of supplemented the other and helped it progressed the other one. They're an addition to each other. Okay.
An enhanced lie. Yeah, you're right.
So quick question on the bending of space-time. Why does it bend it?
I have a problem with calling
in one direction?
Concepts a lie. Okay, because math, there's no agenda or.
Yeah, no. If it's based off a lie, the math is bullshit. Yeah. What do you mean?
Let me ask you a question.
Okay.
Here's some simple math for you. Simple math for you. You have $1 million in the bank, and I'm going to double it every day for 3 days. Tomorrow you have $2 million, and how much do you have the next day?
4. Are you talking
4 million.
About exponential growth?
So you have $4 million in the bank. Math proves it. Math proves it that you have $4 million in the bank in 2 days from now.
Can I see the evidence of that?
Yeah. The problem is you have bad data going into it. Okay. They figured out the distance of the sun because one day Venus, which is about the same size as Earth, transited the sun. And someone on the East Coast and the West Coast saw it start and stop at different times. And they did some really good math to figure out the sun was 93 million miles away. The problem is, got some bad data. They said Venus is the same size as Earth. I think Venus is about the size of one of those yoga balls, okay?
Okay, but I'm trying to yes, I believe in Einsteinian theory of general relativity. I think it's our best understanding so far. I think it can still get better. It can always get better. And just because something has an issue doesn't mean that the things what it explains and predicts is incorrect. Okay, so I answered this problem of the three-body problem. The answer to that...
You answered it was math and physics.
No.
And then you showed me a bunch of scribble on the paper of equations, but you didn't explain how it works.
I can explain how it works. The more mass... let's do the trampoline example, because I'm sure you guys have seen that with general relativity examples. You put the bowling ball in the middle of the trampoline.
And why does the trampoline go down and not up or sideways?
Okay. Oh, this is where you need to start thinking above 2 dimensions, because that example,
3 dimensions. I'll go to 4 dimensions if you want. Why does the trampoline go down? Why does it go in one direction and not this way or that way or that way or that way?
Okay. And that answer is due to gravity, but that's because of the inertial reference.
But wouldn't the gravity pull that trampoline would create like a web around it, because it would have bending trampolines at every possible angle?
Are you guys aware of the formula for like an orbit of the gravitational pull on 2 bodies? You guys know what that equation is?
I do not know how Santa builds his sleigh, bro. I don't.
Okay.
I'll be honest.
The equation, this is why math is important, because it helps you understand how this works, right? So the equation is the force of gravity equals the gravitational constant. I won't get into how we got that because it's a little more complicated. And then you have the first mass and the second
physics
mass.
and physics and math.
You have the first mass. Let's say it's the Earth, and the second mass. Let's say it's the Moon, and then divided by the radius squared. Okay.
The radius. How did you go? Hold on. How'd you get the radius of the Earth?
Okay, the radius. No.
How'd you get the radius of the Earth?
That's a valid question.
Okay.
We don't know. Oh, by the way, if you don't know the radius of the Earth, we don't know the distances or sizes of any of the planets. How did you get the radius of the Earth?
Hold on. Because the radius isn't describing the radius of the Earth. It's describing the distance between those 2 objects. So if you have the Earth here and the Moon going around...
Well, how do you know the distance between the 2 objects if you don't know the radius of the Earth?
Oh, okay. That's a totally separate question. I'm trying to just stick with...
But that question needs to be answered before you can figure out the distances to anywhere else. You need to know the radius of the Earth.
How did you figure all that out?
Well,
for yourself, how did you come up with that conclusion for yourself? Like, what did you have to do? Did you just read something, or how did you come up with this?
Well, school first.
Oh, okay.
So somebody told you.
No, okay. I did the math.
Was it in a textbook?
Joel, did Christopher Columbus discover America in your opinion? Because school said
no. He did
okay. I just wanted to know your opinion on school. But okay.
Okay.
And how old were you when they taught you this stuff?
Okay, hold on. Because I don't agree with a lot of the things that school teaches. I don't even like the school system. So we probably agree there.
Good start there.
I went to the Air Force Academy. I've had quite the experience with education. I went to 3 different colleges, and I don't have my degree. So I've done a lot of my own independent research. This isn't stuff that I was just brainwashed to believe. I've done the math myself, and you can do the math yourself.
Again, you can do math, but if you're based on things that other people are telling you that are unmeasurable. Here's a little experiment we did. We got helium balloons. They're holding this wire in the air. There's a button on the end, and it's just neutrally buoyant off the ground. This wire goes to a Van der Graaf generator, and we're going to crank a negative charge into that pin. And when we crank a negative charge into it, it goes down. Positive charge. Positive charge. Ground is negative. Okay? Positive charge, it gets heavier. Did gravity just increase, or did the electrostatic pull of the Earth just increase? Okay? And then when we discharge it, it goes back up, right? And now we can do the opposite. We can put a negative charge into something, and even though it rises up off the Earth, when we put a negative charge into it, it stays in it because we're still charging it, and it goes up. Is it defying gravity or is it defying an electrostatic force?
Yes. It's doing both. The electrostatic force is overcoming the force of gravity in that instance.
But my question is, things go down because of buoyancy and density. Down is down because, in my opinion, because of the electrostatic force. The electrostatic force is magnitudes more stronger than the theory of gravity, which needs 90+% dark matter and dark energy to make it work.
Exist, yeah.
Right? To make the math work, they'd have to make it up. Normally in science, when you come up with a theory, if it doesn't work, you don't make up crap to make it work. You throw the theory out and you start over. But the electrostatic force is testable. Okay, let's pretend gravity's real, and that's really pretending. How do you differentiate the electrostatic charge effect when I could show you that when I change the electrostatic nature of something, it does the opposite?
Okay, well, I guess there's a couple things there. First,
there are.
Yeah, okay. The first thing is gravity is described as a force, but it's not really like in the sense of like I have my levitating light moon lamp here, right? And it's like just moving above, there's nothing under it. It's just floating.
Magnetism.
Spinning. Yeah, magnetism.
Right.
Okay, so that's an actual force that we can measure and use.
The only two forces that can be measured are magnetism and electricity. The electric force and the magnetic force. The gravitational force is made up.
What happened? Okay, well, you're not completely wrong. Okay, so what gravity is like like a centrifugal acceleration, right? It feels like there's a force, but there's actually not. It's just a result of the motion. Okay, so what gravity is a result of the curvature. So it's not an actual force in the sense of like magnetism or like you pushing on something. It's
Joel, the gravity was created just to protect the ball theory, because without it, I mean, is Australia upside down right now without gravity? They'd fall off, right? So yeah, the gravity, they had to come up with something. That's their false god. That is what they preach, and that is what has led most people to this state of mind of indoctrination.
Well, okay.
Because look, man, when you were little, they could have told you that it was, magical fairy tale rainbows that held the ball in place, and in kindergarten or first grade you just would have accepted it, and we all know we can't verify these stories, especially that's why they had to teach you that at that age, because you have no concept of what they're talking about in any sense of the fashion. So these are made up things. So again, and I don't want to disrespect you, but when I'm talking to people about stuff like this and you're so far this way, it's like, it's like talking to someone about the tooth fairy is real or not real. Like that's how I feel, and I don't want to come off that way. But
no, I don't think you are. I'd like an opportunity to have this stuff because a lot of this stuff can be explained. And
yeah, from there, listen, it could be explained based off of what you read that from the people that don't give a shit about you or me or Dave. So you're representing people that are not in your best interest to represent, man. These are not good people that have come up with this thing. So,
right.
But the explanations are something that you can do yourself, I guess is my point.
Really?
But
okay.
Yes.
So you'd be the first.
Please show us one.
Show us proof of Earth moving. Let's start there. Can we get a science test going to prove the Earth's moving? Because it's never been done. I mean, you'd be a Nobel Prize winning. I mean, you'd be all over the place. You'd have your own Netflix special, brother. If you came up with you'd be the first person to do that.
Are you familiar with the Georgia Guidestones?
Yes, I am.
All right, and they were knocked down, right?
I did. Yeah, I saw that.
Yeah, but you know about the hole in the Georgia Guides?
Yes, I did.
So that hole lines up with Polaris, and it's been up for over 40 years. And the story is, even though we're traveling 4.5 billion miles a year, Polaris is so far away that there's no parallax. That's ridiculous, but let's go with it. But we're also processing. We had our North Star changes, it was 2,000 years ago. It was Steuben or whatever. And, it would have moved at the rate of precession more than 0.5 degree, and it would knock it way out of that hole. 0.5 degree would be way out of that hole. And it wasn't. It never moved out of that hole. Now, I find it quite a coincidence that at the time where this absolutely proves that we're not moving, it gets knocked down. Okay?
Okay. We were talking about before.
physics, science, right here.
Not exactly. I mean, if you can tell me mathematically how this stuff doesn't make sense,
Joe, it's a perfect clock,
right,
brother. Look at the sky. Yeah. It's a perfect clock in the sky.
We're corkscrewing through space in 4 different directions at once, but Polaris never moves from that hole. I'd like you to tell me the math that explains how it never moves from that hole.
Yeah. So the first thing is scale, right? So again, there's these big, vast distances that we're talking about. So when what's the? Do you guys know what the formula for?
Do you mean the distances where we've proven that we can't see Polaris? Okay, go ahead.
Okay.
So now we're dealing with a fictitious distance that we could not see Polaris. The brightness and the size is hundreds of millions of times beyond what we could see. And so now that's going to be.
But Dave, this is what they taught us, so it has to be true.
I know
they taught it to us. It has to give us. It's got to be real.
The science and the physics say that we can't see Polaris. So why are we even arguing about how we see it through this hole?
Okay, because you haven't shown how the magnitude of the brightness wouldn't be seen by us. Okay. And
do you agree that every time you half the distance to a light, it's 4 times as bright? Let me ask you that. Do you believe in the inverse square law of light?
Yes.
You've never seen anything brighter than the sun. If I said better than the sun twice as bright, you'd probably melt. 60 times as bright. That's how bright it would have to be at 100 miles away from the moon. Right? Okay. Short circuit. Well, and you stop thinking about it. Not you, everybody.
No, that's what happens is people memorize these equations. They memorize them, regurgitate them, get a B. Now they want an A, and it's like it becomes. Listen though, it becomes concrete in your veins.
We'll let you finish, Joel. We'll let you finish.
Yeah, my bad. I barely spoke, man. But it becomes concrete in your vein because of the regurgitation and the testing and the studying of garbage. Anyone could come up with any story, any theory, anything. Back it up with math because you're creating the formulas and you're creating the answers based off of bullshit. So what you do, Joel, is you read all this stuff and you're all, and I'm not judging, but you're all involved in the space stuff and it's so cool and everything. Me and Dave used to be like that, man. Like I used to be like that. It's cool. Like, you know what I mean? Like we're different now, but we understand where you're coming from, but you don't understand that you've been programmed. And once you can understand you've been programmed and you can start unprogramming little things from your head and looking at it from a different perspective. So you look at what we're talking about in your same perspective of what you were brainwashed to believe. You don't see it with our eyes. We've seen it with your eyes where you're coming from. We've been there. You cannot understand it from our eyes. That's what sucks.
Let's talk about curvature.
Okay.
Do you believe that the Earth has curvature?
I do, yeah.
Okay, so if this is the Earth and a ship or a building goes farther away, it goes behind that curvature, and zooming in doesn't bring it back because we have a physical curvature. So you agree that the Earth needs a physical curvature?
Yes. Yeah.
What proof do you have? What observation do you have that shows things going over the curve of the Earth? And if I showed you that we could see things that should be far below the curve, but we could see them, what other excuse do you have other than refraction, which won't work, that we can see them? For example, let me show you one example. This is a viewing spot in Illusion, France, and we're looking out as the sun's setting, and out here is Mount Canigou, but you can't see it because it's 175 miles away. Using the Earth curve calculator, at that altitude and that distance, the very top of Mount Canigou should be over a mile or a half a mile to a mile below the curvature. I forget the exact number, but it should be far below the horizon. But our sun, our sun migrates in between the tropics, right? So if my head's the Earth, every year it passes in line with this viewing spot and it lines up. And when it does, the sun is so bright, its light can push to us, but the light bouncing off of Mount Canigou can't make it to our eyes because the air is too thick. But when the sun backlights it, all of a sudden you can see Mount Canigou in all of its glory. The very, very top of Mount Canigou right here should be a half a mile or a mile below the curvature of the Earth, but we can see it. And then with our infrared, we have a channel called J. Tolan Media, or if you check out Sean's film, the next level 2020.com.
2022.
2022, sorry. 2022.com.
Yeah.
There's Jay Tolan is in there. He uses a infrared camera, and he can see things that would make the Earth have to be 1,000 times bigger than they tell us.
At
and
least 1,000 times bigger. At least 1,000.
At least 1,000. But if the Earth was 1,000 times bigger and still a globe, we'd still have a lot of problems. We still have okay, they're lying, right? They tell us there's 8 continents. Well, maybe there's 8,000 continents. Okay?
So I guess my question with that, if you're asking for an explanation, is how high is that mountain?
Well, yes, we calculate in the Earth calculator. By the way, the 8 inches per mile squared is actually better than the 3 other formulas that they use because it gives the globe a little extra favor. It's actually less curvature than the more complicated formulas. And by the way, it only works up to between 500 and 1,000 miles. It gets off a little bit. Like at 1,000 miles, I think it's off by by an insignificant amount. An insignificant amount. But the thing is, you can never see that far. You can never see that far.
The thing with curvature calculation in that specific instance is you're calculating, you got your altitude, your viewing altitude of what you're looking at.
The higher you go, the less curvature there is. We calculate the height of the observer every single time. Okay, every single time.
And that's good. But did it take into account the top altitude of the mountain as well?
Of course. The top of the mountain should be a half a mile or more below the curvature
according
to that altitude.
Yeah, according to their globe math, a spherical math.
You love math. We say observer height, view the object we're looking at, height and distance, and it'll tell you how much curvature there is. Okay.
And it's been destroyed over. This is one out of thousands. Right.
So the curvature of the Earth changes in different areas. It's flatter in some areas.
Well, it isn't. It's not a perfect sphere. First of all,
it's an oblate spheroid.
Right.
Okay?
Yeah, they changed the narrative on that a few years ago. It's an oblate spheroid now. Even though NASA took perfect images of perfect spheres, no one gives a shit about that. But go ahead with your pair.
Well, you should sort of see the shape of it even in the images.
You can sort of see clone copies of clouds and cartoon effects in Photoshop. I've been doing Photoshop since I was 14 years old. Dude, none of those images are real. NASA will admit that. You can go to nasa.gov and look at all their cartoons, brother. Why would they give you cartoons, Joel? Why? There's not one reason to do it, man. You go up there, you take some pictures. Me and Dave wouldn't even exist. But they've never done it, Joel, and they never can. It doesn't exist, brother. That's why they don't take real photos, videos. They don't do a 360 turn in space, because it's all bullshit. Take your camera and turn around and look around and do stuff. What would you do if you were up there with full camcorders? How would you film it? It's never been done that way.
What if you and I were the first 2 guys to land on the moon?
Yeah.
What would the dialogue would be? You know what it would be? Okay, kids, if you have a problem with 4-letter words, leave the room. It would be, holy fucking shit, look at the Earth. Oh my God, look, there's America. Oh my God, look at that hurricane. Holy crap. Never once did the astronauts even mention the Earth.
Nope. And there was one image they released of it. 8,000 images released of the studio set of the moon, right? Because they put a lot of money into that. Warner von Braun, they got some big boys in there. But the Earth? No, that was just to reinforce we live on a ball. They already changed the schools in the 20s, in the 30s. Rockefeller, they changed everything. So they had to reinforce it. Not a lot of people were fighting it at first. They don't want to teach it in school. Teachers were getting pissed off, and teachers that were teaching it in school were getting persecuted. They didn't want this crap taught. It was forced down their throats.
Math is a description of whatever you want it to describe. So if you're going to say, I've got math that proves the shape, the radius of the Earth, show me the math.
I'd love to see it too.
Sure. I mean, we probably shouldn't do it now because we've gone quite long, but I would be perfectly willing to come back on. I could get, because I guess how it would go, right? It'd be like, okay, well, here's the equation for gravity. It goes off of the masses. Okay, well, how did you find out the mass? Okay, well, let's see how we find out the mass of the Earth. And then how do you find out, this, and that? So you have to obviously have starting data and starting numbers to start math, right?
Sure, so, but Joel, once you can admit that all the information that you already have right now in your mind about all this stuff was given to you from someone else, then you can start from there, because none of that information, even though you're repeating it in a sense of your defense, you've done some stuff and tests and equations and like, oh, it does equal that. Oh, yeah. You're invested your emotions into something that doesn't exist. So it's hard to kind of transcribe to you what to change or how to, if you actually are open-minded, a critical thinker, then you'll find all this stuff out. But let me ask you one question, just one question.
Okay.
Did two on September 11th, and the event in New York, and I just want to ask you one question. That's it, just one question. I need to know who I'm talking to here. Do you think 2 planes took down 7 buildings? I just want to know your opinion.
No, I don't.
Okay, you don't. So that's a good thing.
I think it was a demolition, controlled demolition.
Oh, for sure, 100%. But that's a good thing. So you're a critical thinker. This is a big one for you, Joel, because when you were little, maybe you believed in Santa, Tooth Fairy, maybe you didn't. I don't know how your family was, but for the sake of the argument, we'll pretend you did. All these stories, right? And obviously we laugh at them now, we're adults. But this is just the only story that you were never told wasn't true. So it's not that you're an adult and we think you're stupid for still believing in this shit. We don't, because we used to be that same smart adult that you are, right? Until we understood that they're lying about it and we started proving these things to ourselves. We got out of it. But the point I'm trying to make is once you're actually in a mindset to go, let me look into this type of stuff, you need to close your judgment of flat Earth and close your understanding of what you were taught, because you're not just defending something as an adult anymore. You're a child in your mind with this ball. This is when you were taught it, and your parents might have said, my point was, your parents might have said, hey, Santa's not real when you were 6, and maybe Tooth Fairy when you were 5, and so on and so forth, right? And you're like, what? What do you mean there's not real? All that happens with kids. No one told you the ball's not real. So you're holding on to this. Like, I just imagining you right now as a child, just holding on to the globe. You can't let it go because you don't want to. And I feel like you don't want to. And if you did want to, you would. Because once you start dissecting the globe from A to Z and everything in between,
happened to me.
It's over. It's over. But you have to do it without the programming.
We live here, and here are extraterrestrials on the extraterra outside of us, and more out here. These are other worlds.
That's the outer space. That's the real outer space. They put the truth in the words. They know the truth.
So we live here in this pond, right? And then these are other worlds just thousands of miles away.
Star Wars is real, brother. Star Wars is real.
And there might be wars. There might be stuff, territory disputes and all sorts of stuff going on. So the whole Star Wars thing works here on a physically possible flat Earth. Yeah. A scientifically impossible gas ball in a vacuum is not even possible, right? You can't have a gas ball in a vacuum. So space, stop arguing about anything we see in space. It's scientifically impossible. This is scientifically possible. Mm-hmm. That's all.
And why do you think there's a treaty that won't let us go see what's over there? Joe, have you ever asked yourself that question? Whether or not you looked into the Antarctic Treaty or not, they will not let you, your mom, your dad, the richest person in the world, without government clearance, and you ain't getting it. You ain't going to Antarctica to look around and see if there's any other worlds or any other continents. You're not going. Doesn't matter how much money you have. You can't do it. You can go to the peninsulas, the tour-guided peninsulas, and go do your thing there, and then go right home. You can't be like, hey, man, we're going to go cruise around for the next year. It ain't going to happen because imagine what you would find. Your globe's over. There's things there that would prove the globe is done. It's over.
And here's the thing. We're not saying what the Earth is. We're saying, the Earth is measurably, testably level and horizontal, right? Saying flat Earth, well, what does that mean? Level and horizontal, and water proves that. And we're also saying it's scientifically provably not a globe. Those are the claims that we're making. And now, are there lands? Are there extra people and lands? I think so, but we just want the right to go explore, right? But for some reason, they say all of this land bigger than the United States, right? And I think that's just a fraction of a fraction of a fraction of what's out there, filled with resources that no human has ever set eyes upon. How come ExxonMobil isn't going, let us go out there, we'll get you 20-cent gas, right? No one's even questioning this treaty. This treaty is Because if we're allowed to go outside our pen, our playpen, we discover that we're at the center of creation.
Correct.
That we have great power. There is no shortages. We're not overpopulated.
No, Dave. It's just to protect the penguins. It's only to protect the penguins. That's the only reason they do it.
You need the pristine ice also, they say.
The pristine ice. Go look at the Amazon rainforest. Get back to me, Joe. They don't give a shit. They care about penguins. Come on.
And so once you understand why the lie, because they have us in a pen, they have us believe, limiting our thoughts. You know, everything you have in your life is because of the way that you think, right? You create your own world. They don't want us to know how real that is.
Manifestation is
everything
very
I have
real.
in my world. I manifested my world, and I love it because I'm thinking big. I appreciate the civil discussion. You're better than many Globers.
Most.
Not really compliment. I think you're a good guy.
Yeah.
I just think that you're lost in space, and I was at one time. It's no offense, and I'm hoping that one day you see that all of the stuff you brought to us is not factual. You brought some math to us, but not really. You didn't show us how far the sun was. You didn't show us the radius of the Earth. Show us the radius of the Earth. That's the
Show us water bend. No, show me water bending. We'll start from
at rest. Water at rest, bending bigger than a cup of water. Don't show us a drop of water.
Yeah,
show us anything bigger than a gallon of water.
Yeah, water curving. Water has to find and maintain its level. It has to be contained. Yep. Take your bathtub away from your bath. From
Joel,
your,
I'm going to say goodbye.
Joint.
I'm going to hang up because I got to run.
All right, brother.
All right, David.
Thanks. Reach out again after you look a little deeper. If you want to have another conversation, we'll talk about it. Thanks.
Okay, sounds good. Thank you.
Yeah. All right, bye-bye. I don't know if he's capable of waking up. I don't know. He could be smart. I mean, he's got book smarts. Does he have common sense smarts?
Well, book smarts is heavy indoctrination, unfortunately.
Yeah.
But again, just the fact that he can break down 9/11, that there's something in his brain that will allow the critical thought, allow him to trust his senses, because he had to have, Dave. He trusted his own senses with the controlled demolition. We all saw it. So he trusted his senses there. Why didn't he trust the scientists and the official narrative people and the professionals coming forward? And there's full-size magazines about how that the official story was real, and why doesn't he believe any of that? But he believes the same context, the same format of where we live, the people telling us where we live, in the school books. It's like, it's really weird. Usually you don't have someone act like that, but for me at least, I know you said probably not. For me, it's possible still. I'd have to see in part 2, if we do a part 2 with him, I'd have to see where his mind is.
All right.
Yeah.
Amazing. All right.
We will. Yeah, for sure.
Thanks.
All right, everybody.
Thanks
for joining our random show, but love you all, and we'll see you again hopefully soon. So take care.